Hello guys, myself Parshoti Sushant Piraji. I am from Government Polytechnic Nanded. In this video, we talk about nuclear power plant, principle followed by nuclear power plant, working, advantages, disadvantages, application, and their maintenance procedure. Let's start the video. Introduction. Nuclear power plant are the types of power plant that uses the process of nuclear fission in order to generate electricity. They do this by using nuclear reaction in combination with the Rankine cycle, where the heat generated by the reactor converted with into steam, which spins a turbine and a generator. Nuclear power provides the world with around 11% of its total electricity, with the largest producers being the United States and France. Aside from the source of heat, nuclear power plants are very similar to coal-fired power plant. However, they require different safety measures since the use of nuclear fuel has vastly different properties from the coal or other fossil fuels. They get their thermal power from splitting the nuclei of atom in their reactor core, with uranium being the dominant choice of the fuel in the world today. Thorium also has potential use in nuclear power production. However, it is not currently used. As we all of knows, demand of electricity increases day by day. To fulfill this demand, water and coal is of limited edition, so we are required searching newly source of energy for production and fulfillment of electrical demand. To overcome the above mentioned problem, nuclear energy is the best solution to produce the huge amount of electrical energy. This is similar to thermal power plant. In a thermal power plant, coal is used to produce heat energy. On other hand, in nuclear, heat energy is produced with the fission process of uranium, thorium, and also plutonium. A nuclear power plant or nuclear power station is a thermal power station in which the heat source is nuclear reactor. As it is typically thermal power station, heat is used to generate a steam and driven a steam turbine connected to generator that produces electricity. Working. Nuclear reactor is used to produce heat, and heat exchanger performance to convert water into steam by using the heat generator in a nuclear reactor. This steam is fed into steam turbine and condense it. Now steam turbine is turned an electrical generator or alternator which is coupled to steam turbine and thereby producing electricity. This very basic working principle followed by nuclear power plant. Every nuclear power plant consists of four elements: nuclear reactor, heat exchanger, steam turbine, condenser, and cooling water, and also feed water heater. All, as we know, nuclear reactor is the heart of the nuclear power plant. In a nuclear reactor, nuclear fission of radioactive material take place. This lubricates large amount of heat energy. This heat is taken up by the coolant circulation through the reactor core. After absorption, the heat, the coolant become a hot. Next is heat exchanger. The hot coolant coming from nuclear reactors follow through the tube of heat exchanger. In the heat exchanger, hot coolant gives up, up the heat to feed water so that it can be converted into steam. After giving up heat, the coolant is again pumped back to nuclear reactor. Next one is a steam turbine. The steam turbine produced in the heat exchanger is sent to steam turbine. The steam undergoes expansion in a steam turbine and produce useful work in a steam turbine. The mechanical energy is available at output shaft of a steam turbine which is coupled to the generator. Next one is steam condenser, or also we know as condenser. After producing useful work, that is mechanical energy in a steam turbine, the steam is exhausted to condenser. In a condenser, the steam is cooled and condensed with the help of cooling water coming out from cooling tower. After cooling and condensation, exhaust steam is converted to water, which can be used as feed water from the recirculation. This feed water is pumped back to heat exchanger or steam generated with the help of feed water pump. Next one is cooling water or cooling. Next one is cooling tower. After absorption, the heat from the exhaust steam, temperature of cooling water increases, making it warm or hot water. This hot water is sent to cooling tower where is the cool. The cooling water so form is again sent to back to condenser with the help of circulation water pumps. There is a one device used that its name is alternator or generator. Output shaft of the steam turbine is coupled to the generator. Therefore, mechanical energy available at the output shaft of steam turbine to use the generator, which convert mechanical energy into electrical energy. Let's see the working. The element like uranium, thorium are sucked the nuclear fission reaction of nuclear reactor. Because of this fusion, the huge amount of heat energy can be generated and it is transmitted to coolant reactor. Here the coolant is nothing but a water, liquid otherwise gaseous form. The water is heated to flow in the heat exchanger so that the changes into high temperature steam. Then the steam which is produced is permitted to make a steam turbine run. Again the steam can be changed back into coolant and recycled to use from the heat exchanger. So the turbine and alternator can be connected to produce electricity. By using transformer, the electricity which produced can be increased to long distance communication. This is a working principle of nuclear power plant. Sorry. Advantages of nuclear power plant. It is used less space compared with other power plant. It is extremely economical and generate huge electricity power. These plants are located near the load center because there is no requirement of huge fuel. It generates a huge amount of power in the process of each nuclear fission. It uses less fuel to generate a huge energy. It operational is reliable. When compared with the steam power plant, it is very clean and neat. The operation cost is small. It does not produce pollution gases. It is a very big advantages of the nuclear power plant. Let's see the disadvantage. The cost of primary installation is extremely high when compared with the other power station. The nuclear fuel is expensive, so recovery is difficult. High capital cost compared with the other power plant. Technical knowledge is required to operate this plant, so maintenance as well as salary will be high. There is a chance to radioactive pollution. The response is not efficient. The requirement of cooling water is double compared with the steam power plant. Let's see the application. Nuclear energy is used in different industry all over the world for different applications in an industry or also daily life. Desalination of ocean water, that is removal of salt from seawater, production of hydrogen, district cooling or heating, removal of tertiary oil resources used in heat process application like cogeneration, conversion of coal to liquid, help in the chemical feedstock synthesis. Let's see the maintenance procedure of nuclear power plant. Maintenance procedure of nuclear power plant includes two. types: preventive maintenance and corrective maintenance. Preventive maintenance are also classified into three types: periodic, predictive, and planned. In the periodic, time based servicing, part replacement, or overall, including periodic inspection and lifetime replacement, are included. In a predictive maintenance, service lines surveillance, monitoring, testing in service inspection are included. In planned maintenance, condition based servicing, part replacement, overhaul, refurbishment, modification part are included. Then let's see the corrective maintenance. Corrective maintenance are further classified into two types. One is run to failure and second one is unplanned failure. In a run to failure, temporary repair, overhaul, refurbishment, replacement or modification are included. And in unplanned failure, inspection and failure diagnosis are included. Thank you for the watching. I hope you like the video.